We're looking at the system 2x plus 3y equals negative 2, 4x minus 5y equals 18. We want to solve this system simultaneously. Now, by solving the system, we mean we want to find a value of x and a value of y that makes this equation true and also that makes this equation true. Now, we can graph these two equations. It's easy to see that the x-intercept of this equation obtained by letting y equal 0 is going to be negative 1. So we have an x-intercept of negative 1 and a y-intercept obtained by letting x equal 0 of what? Negative 2/3. So we have the point 1 and the point negative 2/3. We can then draw a line, well, the point 1, 0 and the point 0, negative 2/3. Negative 1 on the x-axis, negative 2/3 on the y-axis. We can draw the line through these points. Now, when I drew this line, I didn't exactly hit where I thought negative 1 was, and I didn't exactly hit the negative 2/3, although I came closer than I did to the negative 1. So this line is not necessarily completely accurate. Okay, and there's no way to actually draw a graph and make the line completely accurate. Now, this line consists of all the points for which 2x plus 3y equals negative 2. Any point on this line will satisfy this equation. And any point, any xy that satisfies this equation will be a point on the line. So this line is identified with the complete set of solutions of this equation. Now, the other equation we graph in a very similar manner. We find the intercepts, negative 3 and 3/5 or negative 18/5 for the y-intercept, and 4.5 or 18/4, which reduces to 9 halves or 4.5. We mark where we think those points are, and we construct the line through those points, and that line consists of all the solutions to this equation. The lines aren't parallel. They have different slopes. Any two lines that have different slopes are going to intersect, so these lines will intersect at a point. We estimate that point to be 2.5, negative 2. Now, we're going to calculate in a minute. We're going to calculate that the actual value is 2, negative 2. But that's going to compare pretty well with our estimate. Remember, our estimate was based on a hand-sketched graph with all of its inaccuracies. And also I'll note that these 2 points are pretty close together. So it's really hard to get a really accurate slope through 2 points that are this close together. If the points are further apart, you're more likely to get the slope, you're likely to get a more accurate slope than you will if they're too close together. Too much uncertainty in just where that point is and where that point is. And when the points are close together, that little bit of uncertainty gives you a lot of uncertainty in the overall slope of the graph. Okay, so anyhow, that's the situation. And we proceed to do these solutions. Now, this is going to be a very brief video. You'll be referred to a longer one that was actually done a year ago that runs through this in a lot of detail. But what we do to solve this, and just giving you a brief summary of what we did in class and what people I think did pretty well in class, we multiplied this first equation by negative 2. And I observed that when we multiply this equation by negative 2, actually I didn't observe it here, never mind, that's a different video. Okay, when we multiply this by negative 2, the equation we get has exactly the same intercepts. It's going to be exactly the same line. It's going to have exactly the same solutions as the first equation, the original equation. So we get the equation negative 4x minus 6y equals 4. Identical solutions, identical graph and everything to the equation 2x plus 3y equals negative 2. Now, we add this to the second equation. So we've multiplied the first equation by this quantity, and we write down the second equation. We now have the 2 equations. We can add the left-hand sides. If we add negative 4x and 4x, we get 0. Negative 6x, negative 5 gives us negative 11. So we have negative 11y. And 4 and 18 is 22, giving us y equals negative 2. We take that negative 2 and we substitute it back in for y in the second equation. Because we mucked around with the first equation, we're going to substitute into the second equation, so we're sure to use it as heavily as we did the first equation. Substituting in, we get what I have down here. 4x minus 5y becomes 4x minus 5 times negative 2. Why? Because y is negative 2. And that equals 18, leading to an equation we easily solve for x. And we get x equals 2, telling us that x equals 2, y equals negative 2 is a solution to this system. And if we plug 2 for x and negative 2 for y in the first equation, you can verify that that gives us negative 2. And if we plug 2 for x and negative 2 for y here, it's going to be 8 plus 10, going to be 18. So we verify our solution. Now that's one method of solving the system. Another method, excuse me a minute, is the method of substitution, wherein we solve the first, here's the same system. Okay, we solve the first equation for x. And I'm not going to run through the details of that. You can verify easily that you get x equals negative 3 halves y minus 1. Then we take this expression and substitute it for x in this equation. So we substitute this into the second equation for x. So instead of 4x, we have 4 times negative 3 halves y minus 1. And then that's minus 5y equals 18. We simplify that and solve. We get y equals negative 2. Now I'm going to bring that back and plug it into the original form of the first equation. Doing that, the 2x plus 3y equals negative 2 becomes 2x plus 3 times negative 2, because y is negative 2 equals negative 2. And that gives us solution x equals 2. And again, our solution is x equals 2, y equals negative 2. The point would be 2, negative 2. We could do the same thing by substitution, but solving, whereas we solved the first equation for x, we could do the same thing, but we could start by solving the first equation for y. Here's the first equation. You can verify if we solve for y, we get y equals negative 2/3 x minus 2/3. So we plug that into the second equation and solve. Second equation is 4x minus 5y equals 18. So we do 4x minus 5 times y, but y is now negative 2/3 x minus 2/3 equals 18. We can distribute. Then we can multiply both sides by 3 to clear the denominators. We get an equation here, and that reduces down to 22x equals 44, so that x equals 2. Shouldn't be any surprise. That's what we got for the solution here. That's what we got for the solution here, and that's fairly close to what our graph told us. And again, we believe our equations better than we believe the graph, but the graph gives us a plausibility argument. Okay, then we plug that in to the first equation, and we get 2 times 2 plus 3y equals negative 2, giving us solution y equals negative 2. So everything is nice and consistent.